This question is given in gate 93. The question is, if this is the order in which these statements have to be executed, just write the program with this pair begin parent or co begin co-end, which means we are supposed to write the program in such a way that this is the order followed. So I'm just with example it will be very clear. Just watch it. So first thing is begin, and then we are going to end it somewhere, and inside it I want to have co-begin and then co-end, which means I want to write all these in concurrent manner, right? So what is it? First thing is I am going to begin it, right? So initially I'll just write all the statements and I'll just see what are the semaphores which I need to put before them and after them, right? So I'm going to write it like this: S1 and then end, begin S2 and begin S3 and begin S4 and S5 and then S6, right? Begin S6 and then end. Okay, now which one should get executed first? Either S1 or S6. See this, either S1 or S6, they need not depend on anyone, right? So therefore you need not put anything here or here, so they can directly start. And now after S1 gets over, then only S2 should start as well as S3 should start. So both of these should definitely wait for S1 to get over. So I'm going to write, I'm going to make S1 wait on a semaphore, let us say A, and S3 wait on a semaphore, let us say B. Then who should signal it? The one which should signal it is S1. Therefore here it is going to signal so S1, after finishing S1, it is going to release these two semaphores. Therefore S2 and S3 can start. So here it is going to be V on process to finish. So I am going to put one more semaphore on which S4 should wait, and that should be exactly one semaphore. So let us say P of C, which means S4 is waiting for C, right? And who should signal it? S2. Therefore here I am going to write V on C, right? Therefore this is how the relationship between S2 and S4 is implemented. And if you look at S5, S5 is depending on two statements. One is S2 as well as S4. Therefore S5 should wait for two semaphores, let us say P on D and P on E. Who should signal it? One is S2 as well as one is S3. Therefore S2 should signal, let us say V on D, right? The reason is after S2 signifies this V on D, then only it can start, as well as S3 should also signal it, right? Therefore S3 is also signaling it, right? Now these two will make sure that, see, after S2 and S3 we are putting V on D and V on E, right? And here we are putting P on D and P on E. Therefore S5, it is guaranteed that S5 will. There is one more thing, S4 and S5 should even wait for S6, right? So S4 and S5, they should even wait for two more semaphores. See this, S4 and S5 should not start so easily. So S4 should wait for one more semaphore. Let us say it is P on F and then P on G, right? Who should signal it? S6 should signal it. Therefore S6, after finishing it, it should signal V on F and V on G. V on F and V on G. Got it? So after V on F and V on G, we can perform P on F and P on G. Right? Fine, that is how it is done. Now if you watch it, every statement is going to wait for some other statements, and the number of times we are putting the down operation before it depends on how many times how many statements it is waiting for. For example, if you see S5, it is waiting for S3, S2 and then S6. That is why it is waiting for 3 semaphores. If you look at S4, it is waiting for S2 and S6. That is why 2 semaphores, right? So the number of incoming edges, depending on number of incoming edges, you can recite the number of down operations. And similarly, depending on number of outgoing edges, right, we can define the up on the semaphores. For example, after S2, it is going to signal two process, right, because two outgoing edges are there, therefore two up operations are there. And even S1 is also, watch it, after S1 it is going to signal S2 and S3, that is why two up operations. And similarly, after S6, where is it? Yeah, after S6 it is signaling 2, therefore it is 2 up operations. Got it? It is very simple, and I don't think that they will be asking any questions from this year. Okay.